Hey everybody, Dr. Nelson here. This is a video on linear and nonlinear graphs. Alright, so I want you to do the first 2 pages of the notes. I want you to follow along with me and take notes. And then there'll be some problems for you to try. And then at the end you can see how you did. Alright, so take a look first at this first image over here. Here is a image of a linear function or linear graph. Okay, and down here are 4 examples of nonlinear. All right, so the characteristics of linear functions include, all right, just write this down. The first one is the equation needs to be in at least y equals x format. All right, so remember the value before the x is going to be the slope of the function. Secondly, the domain, which is really the x values of the graph, include all real numbers. All right, so what that means is, okay, on this graph, which goes on forever in both directions, there's always going to be a single x value. Okay, so here we see, x is 1, x is 2, x is 3, x is 4, x is 5, but every single point between the 1 and 2. So, 1.1 or 1.2 or 1.0002, okay? Every single x value, okay, is a real number. The same is said for the range values. All right, now the range values are the y values. Okay? And they also include all real numbers. All right, next, each linear function has one x and y intercept. So one x and y intercept. All right, so if you look over here, this right here is the x-intercept, and this one right here would be the y-intercept. Okay, so there's only one of each. All right, and then lastly, the slope is consistent among any 2 points of the graph. So the slope is consistent. All right, so if you look at the next page of your notes, it says which of the following functions are linear. All right, now the first one, we have y equals 3x plus 2. All right, and you know by now that this is written in slope-intercept form, which means this equation is definitely linear. All right, now let's say if this -2 wasn't here, right? What that would mean is the graph would go through the origin with a slope of 3. All right. Now the second equation, 2x plus y equals 4, we can write that in slope-intercept form by subtracting 2x from both sides. So now we get y equals -2x plus 4. Okay, and again, this time the slope-intercept would be a 4, and the slope is -2. All right. Now the next one we have y equals x squared plus 1. All right, what you're going to learn soon is anytime you see an x squared, that's a sign that the function is not linear. All right, so this one is not linear. All right, and the same thing applies for other powers. Here we have 5x to the 7th. All right, because that number is more than 1, okay, it's also not linear. All right, so now that you know the difference between linear and nonlinear functions, pause the video and try the problems on the next page, and then hit play and you can see how you did. Good luck. All right, welcome back. Let's see how you did with these practice problems. Okay, so take a look at the first graph. Okay, and notice this graph has one y-intercept right here, and it has one x-intercept right here, and it looks like the slope is consistent, so this one is linear. All right, the next graph. Again, here's the y-intercept, here's the x-intercept, and again, it looks like a straight line, so this one is linear. Now look at this function. Here we have the y-intercept is here, But notice we have an x-intercept at this point and also at this point. All right, so because we have two x-intercepts, that's nonlinear. All right, the next one. Take a look. We have a x-intercept here and also at here. And notice this way we have a positive slope and this way we have a negative slope. So the slope is changing. All right, which means this one is nonlinear. All right, here we have a y-intercept and an x-intercept. And the slope is consistent, so that's linear. And this one is really obvious, right? It doesn't make a line. But also we have one x-intercept here and one x-intercept here, which makes it nonlinear. All right, then you have to do some problems on this page based on equations, right? And remember, if you can write the equation in either y equals x format or y equals mx plus b format, all right, it's a sign that it's linear. So this one, we could transform the equation to y equals x plus 3. And that's slope-intercept form, so this is linear. This one here, oh, we got a squared here. All right, that's an automatic sign that the function is nonlinear. Okay, if we graph that, it wouldn't be a straight line. This one here is written in slope-intercept form, so that's linear. 2 plus 2 equals 4. That one is just going to be a point, so that's, we'll call it nonlinear. Here we have y equals x cubed plus x squared. Again, we have a cube and a squared, so that's nonlinear. And last but not least, we have negative y equals 3x plus 8. I can multiply each one of these by negative 1 and transform it to y equals negative 3x minus 8. And now that's written in slope-intercept form, so that is now linear. All right, how'd you do?